Good day. My name is John Vincent Saracanlao. You can call me Sir John or Dr. Saracanlao. We are on our third lesson, which is types of measurements, and assigning codes. And a term I coined, progressive sequencing model, so that we just have a similarity of terms from what I really mean when we talk about progressive sequencing model. So before that, I would like to plug my first book. It's available in Amazon. I'm gonna comment the link if you want to buy one. So it's entitled Constellation of Love, Tales of Tabaran. The summer here is love will always be love, just like a constellation in the sky. In time and seasons are its curtains. It's more of a general overview, but the central lesson of the book is inside, and I want you to discover it yourself. And it's a twist, but it should be something worth reading. Something I wrote when I was in college and decided to not to throw it away and publish it. So it's now here, and I really hope you can also buy this one. And of course, the book about research statistics that will be released soon around second week of February or end of February. So our lesson for today is about types of measurements. There are four types of measurements. So first is nominal. It consists of two or more named categories in which objects, individuals, responses are classified. Data are independent from each other and does not possess order or rank. The best example of nominal data is gender, since male and female are independent from each other, and it does not possess order or rank, which male is better than female or female better than male. So when we talk about data or measurements, there's a certain degree of progression, and it's inherent because I'll explain it later further. So, say nominal, it is independent. You cannot say one is greater than the other, and the other one is greater than the other, or less. So those are nominal data. They are highly nominal, like gender, religion, uh, mm, other variables that you can consider that are independent from each other but does not possess rank or order. The second one is ordinal. The order of position will be measured. The number assigned to indicate one relative position. The rank will be given to the individual along the specified continuum. It does not matter between the distance between position x is greater than y, but cannot say how much. So when you say ordinal, there is order. A, B, C, D, E, F, G. 1, 2, 3, 4, 5. We know that 1, 2, 3, 4, 5 is ordinal, but we know the distance between 1 and 2. As an ordinal data, it doesn't necessarily mean that the distance between 1 and 2 and 3 and 4 is the same, such as what other data? Economic status. Well, you can make that an interval, make it sure that from the first option to the second option it has the same number, but it doesn't have to be in ordinal data. It doesn't have to be the same from one point to the other. So data possess the value of being greater than the other or less than the other, but the keynote in ordinal data is the extent of degree from point A to point B is not definite. The distance to point B to point C doesn't have to be consistent. So if A and B has this distance, it doesn't mean that B and C has have to have the same distance. That's the nature of being ordinal data. Interval, it has the equal measurement. Thus, it is possible to interpret not the order of the scale scores, but also the distance between them. So when we say ordinal, A and B, the distance between A and B doesn't have to be the same distance between B and C. But in an interval, the distance between A and B and the distance between B and C should be the same. We'll explain that furthermore when we go into real data or real information that we can categorize whether they are ordinal, interval, nominal. And the fourth one is ratio. Ratio compares both difference to scores and the relative magnitude of scores. It incorporates the properties of individuals scaled together to a fixed 0 point. Key note is in ratio is 0. It is very similar to interval, but has the value of 0. Time, length, weight. So in interval, A and B has this distance, and B and C has to have the same distance. Ordinal doesn't matter as long as there is order. But in ratio, it's not just A and B, but there's a concept of 0. So any measurement that establishes that there is a 0 point is a ratio. So assigning codes and progressive sequencing model. Numbers and alphabets are representations. They are created by man to represent an abstract or a concrete concept. For example, there is an eraser, a chalk, and a number 1 written on the board. What are the physical similarities of the three? The similarities among the three are the abstract concept of 1 that is inherent to the current disposition. The eraser doesn't need to have a label of 1, nor the chalk for it to have the similarity with the number 1. There are many, there, the tree may have substantial difference such as length, width, mass, volume, etc., which will have consequential effects to the result. The consequence will lead into a greater confusion if there is no understanding of the nature of data and the consciousness when assigning codes. But fundamentally, within the current scenario, there is one chalk, one eraser, and one number 1 written on the board. So, yeah, I get that. I get deep there. So, mm, the point is three different things has inherent nature, and if and those things, if our responses, especially responses, have inherent nature, and that's just number one. What if you go from one point A to B and B to C, and the difference is not the same because it's naturally ordinal? How do you make point to, and it will have consequence on the result if you are calculating substance and referred it as a number. It will be explained for. It's confusing now, but you'll get it along the way. So when using calculating devices, Excel and calculators, codes are both inevitable and necessary. Though SPSS can count non-numeric data or string, however, it is limited to descriptive statistics. SPSS can count non-numeric within the parameters of the subscript in the program. However, as stated in SPSS, data is limited to descriptive statistics. If the data is in string form or non-numeric, the thus values and codes needed to be assigned to the responses in order to process information in inferential statistics. That is why in variable view, see this one, variable view, in terms of measure, there are options of nature of data to be nominal, ordinal, or scale. By default, SPSS will assume data as nominal or unknown. It is the obligation of the data analyst or researcher to change the data type to measures to ordinal or scale, unless it is purely nominal. This depends on the knowledge of the data analyst, or the researcher. In Excel, despite the inequity of what is being represented, it must be numerically represented or coded. One specific example for this is dealing with nominal data. Nominal data are independent from other data. It does not have numerical progressions as responses shift, but it has to be coded with numbers that is inherently ordinal with traits of interval and ratio. Thus, of the chalk erased and a number 1 written on the board, which of which is therefore assigned with the values number 1, 2, and 3. To elucidate the scenario, a data analyst has a variable gender, which is nominal, but needs to code the response. In simple terms, the data analyst needs to use a number to represent a response. This is because calculating devices calculate numbers. It could be any number, but the consciousness that it is nominal data represented by a number that is inherently ordinal is crucial and significant from the beginning of analysis till its end with interpretation of results. Let's go to this one. Okay. Thus, the male or female can be coded as 0 or 1, 1 or 2, or vice versa. 0 male, 1 female, or 1 male, 2 female. It doesn't matter. What matters is that the calculating device can count the number of zeros in the array, which is male or female. The same scenario and implication can be applied with nominal data, such as nationality, color, religion, etc. Thus, codes which are numbers, which is inherently ordinal, may not always have a numerical or ordinal implication, but is coded as such because coding is both inevitable and necessary in data analysis. However, if the data has a progression, it should be arranged and coded progressively, such as educational attainment. As education increases, the code also increases. Progressive sequencing model is operationally used as a term to have a common understanding of what that concept means. Progressive sequencing model means that the information are coded or assigned with codes in a manner that is sequenced to have progression. This is because it is very important that as a researcher is aware that the data can be nominal or ordinal. The data are interval and ratio possess nature to be ordinal. The goal of progressive sequencing model is to establish a term on the use, the importance of assigning codes that are progressive in nature. It is a term to remind that codes and values are assigned should not be randomly given. It is a conscious and deliberate decision on assigning codes and values. The real concern is with nominal data. The data that are ordinal in nature needs to be consciously sequenced progressively. It's a given. This is very important because all information will be coded and with assigned values. The nature of number is progressive 1, 2, 3, 4, even if those data are nominal. Progressive values assigned to the data presupposes that the information is naturally ordinal. The computing devices is not aware that those informations are nominal, though SPSS with the decision of the data analyst can select and identify data, the nature of data, whether it's nominal, ordinal, interval, and ratio, it will still process data as commanded, and the subscript in the program will consider it as ordinal in nature, unless categorized as purely nominal. And all of these information will have consequence on the result. The researcher should be aware that the nature and the assigned values because it has an impact on the result. The absence of the awareness will make the researcher confused. Of the result, in the case of negative t or a negative r, result at the end of data analysis. The consequence can be elucidated with this example. In inferential statistics, specifically t-test, uh, it's very possible that it can happen because along coding and assigned values. The term t-test and negative t will indicate if the second column by value and the calculation is greater than the first column. However, this is based on the identifying which variable is 1 and which variable is 2, and which scores are coded as 1 and which codes values are coded 2 or variable 2. In correlation, a simple misunderstanding of the codes can result to a negative R. So I'll read through first and I'll explain the data later. Uh, Guitar. On the first calculation, male is coded as 1 and female as 2. The result shows as a positive correlation because as the value shifts from 1 to 2, the post-test score also shifts to a higher score. Yeah, this one. The second calculation, by example, changing the codes male to 2 and female to 1, as the values shifts from 1 to 2, the post-test score shifts to a lower value, thus, as a result, to a negative value. All of these can be confusing, but all of these are based on a very simple misunderstanding on the types of data, inherent nature of data, and the values assigned to the data. And it's not limited to nominal data alone, but also with all coded or values assigned. In lieu of that, one solution is progressive sequencing model. One way to use progressive sequencing model is through reference. Instead of randomly using assigned values for gender as male, one male, two female, it is important to refer to literature in relation to the performance. If the study is performance driven, example, in terms of attitude to reading, literature will lean on female to have better attitudes towards reading. Thus, it is suggested to use 1 for male and 2 for female to indicate there is progression based on literature. Another way is to restructure the concept. For example, nationality. Instead of using nationality, which is highly nominal, restructure to other concepts that would categorize the information progressively, such as GDP of the country or type of country. Is it the first world, second world, third world? Which is important. What is important is the use of other categories from which the information can be sequenced progressively. Another example would be residence. Instead of using residence, one can consider distance from school or the property taxes. In consideration to the given example, instead of using yeah, one for first world country and three for third world country, it has to be considered that the third should be coded first world country and the first and one for the third world country. Basically, because there is a need to establish a progression and on the assigned values that they present. 3 as the highest or most positive or the greater value and 1 as least. In fact, there are other informations that are inverse, such as Professor 1 has a higher value than a Professor 4, and in grading system varies institutionally across the world. Some use 1 as the highest and 4 as the lowest, and some use 4 as the highest and 1 as the lowest. So it can be confusing. And going back to this one, let's go to the shifts, okay? So here we have 1 male, 2 female. So as the data shifts from 1 to 2, there is positive correlation also, a positive result because you see 1 is 6, 2 is 9, One is 5, one is 4, two is 8. So the scores of those who have 2 are by face value itself is bigger. So it generates a positive correlation. And we're be careful, we are using a highly nominal information. By example, we changed that 2, we coded it differently, like 2 for male and 1 for female. Notice that the same data, same results, but the 2 has lower posters than the ones. So it created to a negative posters. Same values, same to the last digit, but a negative R. It's a negative correlation because as the value shifts from 1 to 2, the scores from posters shifted from higher to lower. That's the importance of progressive sequencing model because if you don't properly assign values, all those data and all your data and all your calculation are useless and doesn't make sense. It's basically wrong because in the very first place you coded them wrong. Same as here. So when using Excel, the post test in variable one should be the post test and the variable two should be the pre-test because if you do that, like for example, variable one you put pre-test and on variable two you put post test, but we know that by face value alone, post test is greater than the pre-test, so it created a negative t. Same results, same probability value, critical values, everything the same, just a negative one, simply because of a mistake on identifying which one should be variable one or assumed to be greater, and which one is variable two, which is assumed to be lesser. So in this case, it is assumed that the post test is bigger than the pre-test, from which we have a positive t value because basically the post test should be bigger than the pre-test by theory. But if this is negative, then there's something wrong with the paper, and it's and at least with your research, at least you're aware of that. Compared to this one, oh my god, like it's wrong data, and it will can be confusing at the end. So the consciousness at the beginning and understanding progression and coding progressively, and even with nominal data, that awareness of the shift will have implications in the results. It is you cannot randomly assign codes. Period. So that's the purpose of progressive sequencing model and assigning codes. Hopefully, you understand the concept. I really do because I've seen so many papers that are that the results itself is erroneous simply because it wasn't coded properly. And I've seen uh, researchers defending something and doesn't know the statistical implications of a negative R and negative T simply because they weren't aware of the concept. And true that they did it properly, but there was a mix up on the values that they assigned. And it's kind of embarrassing to do that in front of a public forum or in a forum. So I hope you learned something from this lesson. And if you need help, I'm very available to help you. Just comment on the link and we'll find a way to communicate with each other. I really urge you to buy the book itself and also my book one, but it will help. As these videos are just visual reinforcement, though you can always go online to check the tutorials if you're not. I hope you have, uh, but there will be ads. But if you have that book, it's something that you can hold on into and something that you can go through when you forget. Uh, that book is my notes in my master's and my doctor's class during my master's subject in statistics in my master's and my doctor's. I consolidated them all, then I add more informations and data as I go along the way as I taught the subject research statistics to and applied statistics to students in the aggregate level, the master's and the doctor's level. So I really hope you learned something from today, and I encourage you to buy my book. So that's it. Have a good day.